difficult, especially when they show up on the calculator inactive part of the test. So, we're going to make some notes, really of things we already should know how to do, but we have not put it all together yet. So, yep, so you'll write this stuff down. It's just one page of it, so it's not. All right, so for any function that we have, we've got three main types of functions that we have talked about: linear, exponential, and quadratic. Right? On your exam, they are only going to ask you about linear, exponential, and quadratic. There are many, many, many other types of functions, but they're not covered in the Math 1 course. They're covered in other courses. So you will only see linear, exponential, and quadratic. So for all of these, and really all in general, if you need to know the y-intercept of a function, no matter what type of function it is, you just plug in 0 for x. Okay? So every time, plug in 0 for x. Okay. So that works whether it's linear, whether it's quadratic. Now with linear equations, there's another way we found the y-intercept. It is whenever you have a linear equation, it might look like this: y equals 2x minus 7. What's the y-intercept of that? Negative 7. It's y equals mx plus b, so that's another way that we found it. For a quadratic, we had y equals 3x to the third plus 7x minus 2. What's the y-intercept of it? Negative 2. If you plug in 0 for your x, everything goes away, just that last number by itself. What about if I've got something like y equals 3 times 2 to the x power? It'll be 3, should have equals right there, because it's going to be our starting value, right? So that starting value right here would be the case there. So we really kind of had three different ways of finding it, but it's all the same. You're plugging in 0 for the x is what you're doing for each one of these. So you'll plug in 0 for that x. So what is 2 to the 0 power? Is not 0. It is 1. Okay, so anything to the 0 power is 1. So when you plug in the 0, you would have to do the exponent first, which would be 2 to the 0. So you get 3 times 1, which would just give you 3. Okay. So it always ends up being that a value, that starting value there. But in case you get mixed up, and I put a 3 right there instead of a 2, even though it doesn't change the answer. In case you get mixed up with these, you just always plug in 0 for x. It's going to give you the y-intercept. Okay. It's also helpful when we see tables. That's also helpful. For the x-intercept, you're going to plug in 0 for y. It's just a slide. I don't know if it'll take a whole page on your notes or not. But Julie, stop. All right. Okay. So if one big thing that we're going to look at today is what we're going to do when we're looking for the value of a function. For example, when x equals 3. So it might say, what is the value of f of x when x equals 3? Or that 3 could be any number. It could be 7, it could be 100, it could be negative 2, it could be any number. You're just going to plug in that number for the x. And so, again, whatever, I just use the number 3. Whatever number x equals, you can change it over here. If I said x equals 7, we'd plug in 7 for our x. Okay. In a very similar manner, if we have something like the value when y equals 7, and again, 7 could be any number right here. We would just plug in 7 for y. And here I might should say this. This will give you the y value when x equals 7. This will give you the x value when y equals, I'm sorry, y value when x equals 3, x value when y equals 7. This is really the same as the y-intercept, but if the question asks you for an initial or a starting value, you're going to plug in 0 for x. You might want to put right here that that'll give you your y-intercept. Alright, so if the question asks you for initial or a starting value, which it may do with really any type of function, it's more likely to be on exponentials, but it could be on any of them. You're looking for that y-intercept. Plug in 0 for your x. Mm-hmm. I should work on that. Have I told y'all about my cousin? I've told you about my cousin, haven't I? My cousin Landon. His hands look like this. I've told you before. Like they're not really deformed, but they like his feet. He has normal hands that, if he could straighten them out, would look like this. But he can't straighten, like his muscles and his nerves will not let him straighten his hands out. So they're normal, but they're always in this position. So he would have to take this pen here like this and do like this. And then he rests one hand on the other like this to write. And his handwriting is better than half of yours. So we can make excuses if we want, but I think everybody in here has fully functioning hands and arms. So be grateful for it and take your time and write it so you can read. Not everybody may have the most beautiful in the world handwriting, but if you take your time, you should have at least legible handwriting. Okay. All right. So we got a couple more things. Okay, this is for quadratics only. Okay, so quadratics only. Line or an exponential is not going to have an axis of symmetry. Not a vertical or horizontal axis of symmetry unless it's vertical or horizontal line. So, my dad, here, let me tell you another excuse over there. My dad, when he was 17 and in high school, had cancer, bone cancer in his right arm, had to have his right arm amputated at the elbow, and had to switch to his left hand. So he had to go from being right-handed to left-handed, and he's not naturally left-handed. He can also write better than you guys. 60. It did take, I'm sure it took him a little while, but, my whole life he's been able to write perfectly fine left-handed. Because it was so long ago, whenever he lost his arm, he does have like a hook, like a arm that goes on his arm with like a hook on it because it was it. He's got like he's got like a nub right here. They took it right below the elbow, so it has like a strap that like goes over his arm here, and it has like a strap that goes over his shoulder. I think is how it attaches. He never wears it, but he does wear it every once in a while. But it does have a hook. He had a CDL. He doesn't have it anymore. He let it go because he doesn't drive a truck much. But he had a CDL, and so they required him to have it to drive a CDL, like with the CDL. But so he had it for that. But it was like an ancient prosthetic, like they made it for him shortly after he lost his arm 40 years ago. So he has basically just learned how to do everything with one hand. There's not much that he cannot do, and he would, whenever he drove a truck, he always kept it in the truck. He didn't necessarily always wear it like he was supposed to, but he kept it in the truck so he could put it on in case he got pulled over. I don't know. He reaches across and he can drive a straight gear vehicle. Like he's the one who taught me how to drive a straight gear. He bought me a straight gear whenever I was 16, and I had to learn how to drive it. And he would teach me how. Like, he reaches through the steering wheel and does like that. And he can use, like, the whole... Yeah, he can drive a bulldozer. Like, he can drive... Yeah, like all the equipment at the sawmill, he can drive all of that stuff. I mean, I'm not saying he can do it. He can do it pretty good. Somebody with two hands obviously has a little advantage, but he's pretty good. So, anyway. And he had to switch to being left-handed, and he can write better than some of y'all. So, take your time. Just think about what it would be like if you had to switch to being left-handed. Yeah, if you had to switch to your non-dominant hand, I should say it like that. Yeah. All right. Yeah. Okay. Vertex. Vertex, your x coordinate is going to be negative b over 2a. To find the y, plug x back into the equation. So once you get the x, you'll plug it back in. So this is fairly recent. You should hopefully remember it, but let's write it down one more time. Just to make sure. And I have heard of studies, and I believe it, that like actually writing down helps your brain remember things better than like typing it into a phone or just reading it. The act of actually writing it down on paper. So I won't make you write too much, but I do. I take notes and never look back at them, but it helps me remember things better.
When I think Coach Edwards as my teacher, we read I also mentioned that I made a 70 pop.
Now, do you know Discovery Education, like the big paragraphs it gives you? Like, you better try all that.
I'm not saying that just writing things down is like the only and best way to remember it, but it does help, I think, to write some things down. All right, for linear functions, one we may have forgotten is our rate of change or our slope. There are several different ways we talked about slope, change in y over change in x, rise over run. The formula we use sometimes is y2 minus y1 over x2 minus x1. So let's copy that down as well. And while you're copying that, I'm going to give you the problem. Yes.
Oh,
Wednesday or Thursday. I'm not sure which one it's going to be. All right, we're going to do C together, and then I want you to do D, E, F, and G by yourself. So for C, it asks us for us to list the functions in order from smallest to biggest when x equals 2. X equals 2. If I graph x equals 2, what does it look like? It is a vertical line, right? So x equals 2 would look like this. Let me use the purple right here. It would be a vertical line right here. So, at x equals 2, if I'm looking at graph A, okay, for graph A, my y-coordinate there is 8, right? So 8 is my y-coordinate for that one. For graph B, for my green graph, it looks like we're probably about at -2. Right there, it almost runs off the page, but I think it's about -2. And for C, we're almost at 0. We pretty much have a y coordinate of 0 there. It's actually a little bit more, but that's okay. So, which one of those has the highest value? A. Next would be C, right? That red dot right there. And then the lowest would be D. Oh, I did put them backwards, and there's no D. I'm losing my mind. It is smallest to greatest, so let's try this again. Smallest would be B, right? The green graph. Then middle would be C, and then greatest would be A. Sorry, I had those backwards. Smallest to greatest. We should have started with the lowest one there. Okay, so you guys get the idea there? So the next one is going to ask you about when x equals 5. So x equals 5, and feel free to draw this line in. I would encourage you to do so. Is going to be the vertical line at x equals 5, like this. So think about the y-coordinates at those points. And I want you to put those in order. So go ahead and do C through G for me. I want you to list your list in smallest to greatest on those.
The points you have are perfect, and it would be, yeah, it's going to be like between 0 and 1, it's like half, which is fine. But you don't have to like actually list it, you just have to show that that's the lowest. So C would be first. You don't have to actually give the values on this, you just have to tell which one's lowest and next. Right.
All right, Julian, what'd you get for D? Okay. Looking for least to greatest. It's the one I got drawn right here. X equals 5 is this vertical line. Which graph's the lowest? Yep. And then the middle. Good. And then B. So you have C, A, B for that one. Okay. For E, we're looking at 7. So, Vince, what do we have at 7? So, if I look at 7, the blue graph hits that line right here. The green graph hits the line right here. The red line hits the graph right there. They all have the same value, right? So that one's a little bit of a trick question. They're all the same. So you can't really list them from least to greatest because they all have the same value. Okay? Passion for F, we're looking at x equals 9. So x equals 9. It's going to be this line here. Now this one, I can't see where they cross, right? So I see where A crosses. A crosses right here. I don't know where the green graph or the red graph cross. But I do know that this is going to continue down in this direction forever, and this one's going to go up in this direction forever. So which one's going to be the lowest once it finally gets to 9? The green graph here is B. So B is going to be first. Then the middle one would be A, because it's in the middle here. And C would have to be the highest here. And then for G, Caroline, for G, they ask us about x equals 15.
I don't think there would be an arrow. Maybe like A.
The graphs will still exist because whenever these graphs are drawn, it's like they've got arrows on the end. So they keep on going forever. If you think about graphing it in Desmos, like you could keep zooming out. It just keeps on going. It would be there. It's going to be BAC again because even though we can't see what happens here, nothing's going to change from x equals 9 to x equals 15, right? That green graph is going to keep going down, 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 down forever. It's going to be on the bottom. A is going to continue to decrease, but not as quickly as the green graph, so it's going to be in the middle. C continues to increase, so it's going to be on the top. Okay? All right, don't pack up. We got 6 minutes. Don't pack up. All right, so which functions have a positive rate of change throughout the entire graph? That's all right, for H, only C. C is the only one that's increasing it. Does it have a constant rate of change? It does not. Constant rate of change would mean it would be linear. It would be increasing by the same amount each time. This does not have a constant rate of change, but its rate of change is positive because it's increasing. Okay? For I, which functions have a negative rate of change throughout the entire graph? That is A. It is always decreasing. Is it a constant rate of change? It is. It's decreasing by the same amount each time, right? You have a slope there. You're going down 1 over 1, down 1 over 1, down 1 over 1. It's a constant rate of change. All right. And then J, which graph has a rate of change that is negative and then positive? Are you sure?
C.
Well, actually, okay, sorry. If if it is the way I said it, I said negative and then positive. Is there anything that has a negative and then positive? No. Because this one is positive and then negative. But does that question actually have the word then in it? I just put it in there, didn't I? So, negative and positive, it doesn't matter what order it's in. B. Is your answer there? All right. K. Which function has the largest ROC? What do you think ROC stands for there? Rate of change from 3 to 5. So 3 to 5, we're looking at this area right here. So in this highlighted area. So when we're thinking rate of change, I want you to think about how steep your graph is. There's one of these we can rule out right away. It is not C. I mean, it is A because does A even have a positive rate of change at all? It's decreasing. So A is decreasing, it is out. It's not going to have the largest rate of change. C and B are both increasing, but which one is steepest? B. C is barely increasing at all. It's not very steep at all. The green graph is definitely the steepest. So for that, we will get B for that one. All right, now it asks for L. It asks us for the largest rate of change from 7 to 8. So this time, we're looking for between 7 and 8. Okay, which one has the largest rate of change here? It's C. It's the only one increasing at this point, right? The other two are decreasing here. So we would have C. Okay? All right, so look real quick at the back. I'm going to explain what I want you to do. So, let me look. All right, so for C, get rid of that. All right, for the back, all right, it's going to give you a table and a graph. All right, and it's going to ask you to compare, like for example here, compare the y-intercept. So you're telling me which one is the highest here. So what I want you to do, you can use anything you would like. You can use Desmos if you want. It's a good idea to graph this in Desmos, so it'll let you be able to see what you're looking at and compare it to this graph. But I want you to answer that question about comparing those. Then why is it not working? Okay. Then here, it's got two quadratics. It asks which ones has a smaller minimum, bigger y-intercepts, x-intercepts. You can graph these in Desmos. I want you to answer those questions, okay? And then x-intercepts here, it says it's okay to estimate. So I want you to do those just few questions on the back for me for homework, and we'll talk about them tomorrow.